Deploying resources is very easy nowadays. You can build powerful infrastructure, like Azure Kubernetes service clusters or robust databases, with just a few clicks or a single command. This is good for innovation and TTM, but it also creates a challenge: controlling cloud cost. Many organizations struggle with unexpected high bills because cost management is seen as an afterthought, not as a core part of the engineering process. This video will show you how to solve this problem by implementing FinOps-as-Code. FinOps is the practice of bringing financial accountability to the variable spend model of the cloud. By integrating open-source tools into your infrastructure as code workflows, you will configure automated guardrails to ensure that your cloud usage always aligns with your business budgets. In this video, you will set up a system that automatically checks your resource deployments against defined budget policies before they go live on Azure. You will use open-source policy enforcement tools to define which resources are allowed, what their size limits are, and how much they are allowed to cost. When you are finished with this video, you will have a working FinOps-as-Code control gate that can prevent budget overruns and enforce financial accountability, which you could directly integrate in your GitOps or DevOps process. This approach is much more proactive than just looking at the bill after it is already too late. Effective cost control requires more than just monitoring your spending. You need to prevent unwanted resource deployment before it happens. This is where FinOps-as-Code comes in. It translates financial rules into technical policies that are enforced by automation. In this video, we will use the Open Policy Agent, an open-source general-purpose policy engine. OPA is an important tool for cloud-native governance because it lets you define policy across your entire stack, from infrastructure to application code, using a high-level declarative language called Rego. Rego allows you to write rules that evaluate JSON input data against a defined set of policies. For instance, a Rego policy can check cost limits to check whether a requested Azure Virtual Machine SKU is too expensive for a specific team. Compliancy to check if all resources have the correct FinOps tags for cost allocation. And resource size to check if the node size of an Azure Kubernetes service node pool exceeds your established maximum size for development environments. If you are integrating OPA into your CI/CD pipeline, you establish a control gate. If a deployment plan violates a budget policy, OPA rejects the plan, forcing the engineer to correct the resource configuration, thereby preventing unexpected costs. Before diving into the next steps, ensure you have the following prerequisites in place. You'll need an active Azure subscription with owner permissions to create and manage resources in Azure. You'll also need one Ubuntu 24.04 server that you can connect to via SSH. This will serve as your control plane. And you'll need a local development environment for editing files. In this video we will use the Nano editor on the remote Ubuntu machine for demonstration purposes. Let's get started. First, you will connect to your Ubuntu control plane and install the Open Policy Agent binary along with necessary tools like curl and JQ. Let's connect to your remote server via SSH, using the command SSH, followed by your username at your server IP address. Once logged in, use curl to download the OPA binary and move it to a directory that is in your system's path. This allows you to run OPA commands from anywhere in your terminal. Run the following command: curl opa https://github.com/open-policy-agent/opa/releases/download/v1.9.0/opa_linux_amd64. All these commands can be found in the blog article that is mentioned in the video description. Use sudo to move the downloaded file to the user local bin directory, which is typically included in the path, and make the file executable. Run move opa user local bin. Then run change mode +x user local bin opa. Finally, check that the installation was successful by displaying the OPA version. You will also install JQ, a handy tool for processing JSON data, which is useful when working with OPA. Run OPA version. You will see output similar to mine. Next, install JQ using the apt package manager. Run sudo apt update and sudo apt install yjq. You have now installed the policy engine OPA and the tools required to start defining and testing your FinOps guardrails. In the next step, you will write a policy that enforces cost constraints on your AKS cluster nodes. Now it is time to create the policy file and write the Rego code. This policy will prevent the deployment of expensive, large node sizes, in terms of VM SKUs, for any AKS node pool that is tagged with the key environment and value dev. First, use the nano editor to create a new file named aks_cost_policy.rego by running nano aks_cost_policy.rego. Inside the editor, add the Rego code from the blog article. The purpose of this policy is to identify and deny VM SKUs that are larger than the allowed maximum, but only for resources with the environment dev tag. Now, press Ctrl+O and hit Enter to save the file. Next, press Ctrl+X to exit the nano editor. You have now defined a high-impact policy that directly links FinOps guardrails to configuration data using Rego. With your policy written, you need to test it against configuration data. We will simulate a deployment plan by creating a JSON file that represents an AKS node pool request that violates our rule. Let's use nano again. This time to create a new JSON file named violation_test.json. Run nano violation_test.json. Add the JSON from the blog article. Take note of the defined VM size, which is the standard D8SV3, and the required environment dev tag. This should trigger a denial. Save and close the file. Now, execute the OPA test command using the eval flag. This command is OPA eval aks_cost_policy.rego I violation_test.json data.azure.aks.cost_control.deny JQ. The command tells OPA to load the policy file aks_cost_policy.rego, use the violation_test.json file as input data, evaluate the specific data.azure.aks.cost_control.deny rule in your policy package, and pipe the output through JQ to format the JSON result cleanly. You will see output similar like mine, showing a deny message. The output shows the exact denial message you defined in your Rego policy. The policy evaluation returned a denial, successfully acting as a budget guardrail. To confirm the policy only targets violations, you will now test a successful deployment. This deployment uses a smaller, more cost-effective SKU, the standard D4SV3, which is not in the denied_SKUs set. Open the JSON file again, by using nano again. Change the VM size property to a permitted size, using the data from the blog article. Save and close the file, and rerun the OPA evaluation command again. This time, the output will be an empty array, which indicates a successful compliance check. The policy did not return any denial messages, proving that the AKS node pool configuration is compliant with your FinOps rules. In this video, you configured and tested an important component of FinOps-as-Code on Azure. We successfully demonstrated how to define financial guardrails using the Open Policy Agent and its Rego language. By creating a policy that restricts expensive AKS node sizes based on the resource tag, we have established an automated, proactive gate that enforces budget compliance directly within your infrastructure deployment process. If you are integrating this policy check into your CI/CD or GitOps pipeline, you can ensure that cost control is a mandatory, automated step for every Azure resource deployed. It will move you beyond simple cost monitoring, towards true cost prevention. To learn more about FinOps and how it can benefit your specific scenarios, I recommend following the links from the blog article, which is shared in the description below. Thank you for taking the time to go through this video and making it to the end. Stay tuned, because we will keep continuing providing more content on topics like this in the future.